Today I want to talk about empirical and molecular formulas. Empirical. Now, probably the best way to understand that actually is talk about ratios, all right? Mr. Sams, what is the ratio of fingers to hands that I have?
I see 2 hands and 10 fingers.
So I have 2 hands and I have 10 fingers. That's not a ratio, Mr. Sams. I mean, it kind of is, but what's the real ratio? How would you actually express that?
Well, in like lowest terms, it's 1 hand for 5 fingers.
So 1
to 5.
to 5.
Yeah.
So that's the ratio, right?
Yeah, but that's not really how many fingers and hands you actually have.
Yeah, see, this is an analogy. In the last podcast, we learned about empirical formulas. An empirical formula is the lowest whole number ratio. So the lowest ratio is 1 to 5 that I happen to have. But that really does not accurately describe me. I really have 10 fingers and 2 hands. So my actual ratio is 2 to 10. This is more accurate, isn't it? And this is just the lowest ratio. You see, chemicals can actually work this way as well. So for example, I can have the chemical C6H6. This is called benzene. Well, benzene is the molecular formula. The empirical formula is CH, because the 6's can reduce to CH. It's a ratio of 1 to 1. And so this is the actual formula, where this is the empirical formula. Now we'll show you how to do all the calculations, well right now. So let's get to the podcast. So podcast 3.7, molecular formulas. So let's talk this through, Mr. Sams.
Okay.
All right. All right. Hey, go forward.
There we go.
All right. So what is this whole molecular formula thing?
All right, so molecular formulas, they're, like it says, they're whole number multiples of empirical formulas. So just like Mr. Bergman's 5 fingers to 1 hand, he multiplied it by 2 to get his actual 10 fingers to 2 hands.
So if I've got CH, what would that be?
That's an empirical formula.
That's an empirical formula. But I happen to know, for example, there's a chemical called benzene.
Okay.
And benzene's formula is C6H6.
Yeah.
What did you do?
It multiplied it by 6.
You times it by 6, a whole number. It wouldn't be like 6.2 or 8.3, or you multiply by a whole number, in this case 6, to get benzene. Let's do some examples on how that would look. So which of the following is an empirical? It's a little multiple choice for us here.
All right, so which of these molecular formulas are also empirical formulas? Meaning,
too far.
Which of them are also the lowest whole number ratio?
All right, so if I look at this C5H10O5.
Okay, that is not the lowest ratio of all those numbers.
I can see it. Think about just reducing fractions, guys. The 5s and the 10s are multiples of each other.
Yeah, we can divide all those by 5. So it would
the
be
empirical,
C, H2,
H2O. And that would be the empirical formula. And this is the molecular formula. I like to call it the actual formula.
Right.
This is the real formula. This is just the empirical. Sometimes the empirical and the molecular are the same, but not all the time. This next one, same problem.
Right, I can divide all of those by 2.
6.
No, by 2.
By 2, you're right.
Yep.
So I can get C3H6O. That's empirical. That one is reducible, so therefore this is a molecular formula, M to F. This is a molecular formula. Now this one, oh my gosh.
No, there's an Mg1 in there.
Yeah, there's just
only one magnesium,
Mg.
so you can't divide 1 by anything.
This is the empirical and the molecular formula.
Yeah.
What in the world is that?
I have no idea, but it's big.
Does that really exist? Probably so.
Maybe. It's probably like an enzyme.
And this one would too. This would also be this. So this is an empirical formula. This one also is an empirical formula. Whenever you have 1 of something, you're done.
Yeah.
1 O and 1 N. You can't reduce 1.
1, you're done.
Yeah, 1, you're done. There you go. Good. All right. So now let's kind of combine the last podcast with this one.
All right.
So what we want to do is we want to say what is the empirical formula and the molecular formula of a particular compound.
Because in order to get molecular formula, you have to know the empirical formula first.
So we have percentage, so we're going to play the game. Percent to mass to mole times all times the whole. Yep. Did I say that right? That was a little bit fast.
I think so.
Very fast. Percent to mass, etc.
Yeah.
All right, so let's have a blank screen to do this. You got the numbers?
Yeah, I do. I got them written down.
All right, let's do H here. Actually, let's do H first and then O, because actually I know what this is. H is 5.9
percent
grams
to mass.
Percent to mass.
Okay.
And this will be 94.1 grams over 1. Okay.
All right.
And then I'm going to say, I'm going to say 1 gram to 1 mole. Again, I'm not being a little bit naked here because I need the space.
Yeah.
All right, so that's 5.9 moles. Okay? And this, I'm going to take this, and I'm going to say 16 grams in 1 mole. Mm-hmm. And I happen to know the math on that. That's going to be 5.9 moles.
Okay.
So what do you do?
Divide by small.
Divide by the small. Hey, they're the same number, Mr. Sams. So 5.9, 5.9, and you get 1 and 1.
1. So the empirical formula here is...
There we go. So HO.
Yeah.
That's the answer. We're done.
That's the empirical formula.
Oh, what do we need to do?
It asks for molecular formula.
Actually, let's go back a screen, guys, and let's take an important note here. It said that the molar mass is 34 grams. So we have one more piece of information, that the molar mass is 34 grams per 1 mole.
So in order to get from empirical formula to molecular formula, we need to know the molar mass of both the empirical formula and
so
the
I want to find the
formula.
empirical weight.
Yes.
So if you look in your periodic table, hydrogen weighs 1, oxygen weighs 16. 16 and 1, Mr. Sam, pretty easy, 17.
Yeah.
So 17 is not the same as 34.
No.
But it is a multiple, or a factor, actually.
It's a whole number
a factor of 34. So 17 times what is 34? This is easy.
2.
It's times 2. Or you might just realize you're going to take your
34.
molecular mass,
Yep.
divide it by your empirical mass, and see what number you get. In our case, that's 34 divided by 17. This is very easy. And if you don't get a whole number, you've done something wrong.
Yeah.
It should be 2, 1, 2, 3, 4, some nice round, even number.
Yep. So this one's 2.
That means that the formula is half as big as it needs to be. So
Right.
I need to times my formula by 2.
Yeah.
So that means it's going to be H times 2. This 1 now becomes a times 2 times 2, H2O2.
2. So that's the molecular
This
formula.
is the real formula. It's kind of like my hands and my finger analogy at the beginning of the podcast.
Yep. So we take the empirical formula times the whole number that we get when we divide their masses to get the molecular or the actual formula.
And this is better known, by the way, chemical land people, chemistry people of hydrogen peroxide.
Yeah.
You've probably got sitting in your shelf at home. Okay, let's do another one.
Okay.
Well, let's do another example, Mr. Sams.
Alrighty.
So here we have a chemical that contains 43.6% phosphorus, 56 oxygen, 56.36.
Yeah.
And we know its molar mass. So what's the empirical and the molecular formula?
Okay, so we have to start by getting empirical first.
Yep.
And
Okay.
then we go to molecular. So percent to mass.
Percent to mass game. Okay. So it's phosphorus.
Phosphorus, yeah. It's 43.64 grams now, percent to mass.
And then the oxygen.
56.36
56.36
grams now, because it's...
Yeah, I'm percent
to mass.
Percent to mass. Now, guys, what you're going to need to do, let me back up. I would really recommend that you copy down this question.
Yeah.
And then work the math out. Don't just write down the answer. You're not going to understand anything. So copy this down. So you should push pause and then come to here. Okay. And so phosphorus has a molar mass, look at the periodic table, of 31 grams in 1 mole. And oxygen is 16 grams in 1 mole. So, Mr. Sams, we're not going to put the calculator up because Mr. Sams has it worked out already.
1.409.
1.409 moles of phosphorus. And the oxygen would be
3.523.
3.523 moles of oxygen. Now, those don't really we don't see.
No, divide by small.
Divide by small.
Yep,
Okay, 1.4.
1.4.
1.409 moles. That would be 1. 1.409 moles. I don't know. I'm going to guess 2.5.
Yep, 2.5.
2.5.
Okay. Divide by small.
Divide by small.
Times till whole.
Now this is at a half.
That's a 0.51.
So we talked about that last time.
Yep.
Times it by 2. Now notice I do like a big parentheses. That means everything's times 2.
Yeah.
So 1 times 2 is 2, and 2.5 times 2 is 5. So this is P2O5. Bingo.
Okay, so that's the empirical formula.
This is equal to the empirical formula, but that's not the question. It asks for the molecular formula.
It does.
So you're going to have to figure out how to do that. So let's just new screen here.
Okay.
So our empirical formula is P2O5.
Right.
This is the empirical formula.
And we need to find its
molecular
mass.
formula.
Right.
So let's get that one other piece of data that we haven't used yet, and that's this 283.9. I just did that quick. But the molecular weight is 283.9 grams per mole. So I want to find out what the empirical, not formula is, but weight is. So the empirical weight would be 2 times 31. Phosphorus weighs 31, plus 5 times 16.
Right.
And I'm going to guess that that's like 141. Mr.
Yeah, it's
Sands?
142.
142.
Yeah.
Okay, 142 grams in 1 mole. Mr. Bergman, I did that in my head pretty well, didn't I?
Yeah. Good thing I had it written down next to me, huh?
Well, I didn't look.
Oh.
I didn't look at your answer.
You cheated, though. You didn't actually do it.
Yeah, well, yeah.
I know what you did.
But 142 is a factor of 283, isn't it?
It is, yes.
Because if you would times this by some number, you get 283. Actually, the reason I knew this, 284. And so if I were to times that by, well, 2, I'd get 284, wouldn't I?
Yep.
So the real formula needs to be multiplied by 2. So the real formula is 2 times 2 is P4O10. Now, do you know what P4O10 is typically used for, Mr. Sam?
To make phosphoric acid.
It does make phosphoric acid, but actually this is a huge ingredient in fertilizer. So if you go to, buy just any old fertilizer and they say the phosphorus in it, this is the chemical that's there.
Interesting.
And this is what produces the phosphates in the
Fun,
yeah.
Tetraphosphorus decoxide.
Yeah, a little tetraphosphorus decoxide. So now I want to say something. We're not going to do another example here, but I do want to say sometimes this number could be a 1.
It can be 1.
Where the empirical formula and the molecular formula are the same. Kind of like my friend who has 5 fingers in 1 hand. He was born without an arm. And so it can happen. It's not that often, but you'll see a couple of examples in your homework where you're going to see that.
Yep.
So, okay. I think we're done with Chapter 4.
We are.
Or Unit 4.
Unit 3.
Unit 3.
Yeah.
3. Whatever.
4's next.